We are discussing the module 7 of the organic chemical technology course, and in the module 6 we discuss about the petroleum refinery and the FCC. In the lecture 2 of the module 7 we discuss about the naphtha and gas cracker, because the next lecture will be the recovery of the C4 and C5 gases from the FCC and the cracker plant. Actually, you see, I am not going. I have already discussed in detail about the FCC in the module 6. What are the products we are getting? What are the development that has taken place in case of the your FCC? How the changes are taking place? Now the FCC that is being operated in propylene mode, and even the recovery of the C3 gases, propylene from the FCC, that will be discussed while discussing the propylene and the module 6 of module 7 and in the subsequent lectures. So, I am not going to discuss here the C3, only here what we will be discussing in this lecture, that is the recovery of the chemicals from FCC and steam cracker C4 and C5 gases. This will be the coverage of the lecture, introduction of the why we are going for the recovery of the C4 C5 gases, what is the importance of these C4 C5 hydrocarbons, upgrading of the C4 and C5 cuts, because how to separate from the C4, because many of the fraction which you are getting here hydrocarbons, they are having a close boiling point. How to, because this was only became possible with the development of the adsorption technology, with the development of the some of the solvents. Otherwise, earlier it was the separation was also difficult of the close boiling component. Similarly, in the C5 also the same problem was there. So, typical composition of the C4 and C5 fraction, because many of the products which are getting from the C4 and C5, they are very important valuable petrochemical feedstock. So, we will be discussing in detail about the product profile of the C4 and C5 hydrocarbon. Then the processing of the C4, C5 cut from the steam cracker and the FCC. Separation of the butadiene, isobutylene and butenes. These are the three very important raw material which we are getting from the C4, C5 cut for the organic chemical industry or the petrochemical industry. Isoprene and cyclopentadiene, that is from the C5. Another very important is steam, and the earlier actually we started making the MTBE or ETB or the steam, that was the oxygenate from the C4 and C5 cut, and especially the MTBE. And as I discussed earlier, that there was some problem in case of the MTBE, leakage of the MTBE, and as MTBE is highly carcinogenic, then in some of the developed countries there is ban on the use of the MTBE as oxygenate, but at the same time MTBE which you are getting, that can be cracked to get isobutylene for the synthetic rubber, because the pure isobutylene that you can get. Ethyl tertiary butyl ether, again that is one of, here instead of methanol that we are using ethanol, or the steam, that is what we are getting from the C5 steam of the cracker plant. With the rising demand of the ethylene and the propylene, there has been a tremendous growth in the steam cracking of the hydrocarbon during the last 4 decades, and as I told you that now the FCC, that is the integral part of the any refinery. You cannot imagine a refinery with the FCC or the hydrocracker. So, FCC, so with the coming and with the requirement of the propylene, we are going to have more and more FCC in the gas, in your gasoline as well as the propylene mode. So, even the steam cracking, because just to meet the requirement of the rising population, which is going to be 7 billion world population, 1.3 around 1.2 plus in India. So, how to meet that requirement of the various chemicals. So, the steam cracker and the FCC, they are playing very important role, and lot of the development that has taken place, and new furnaces, new cracker plants, and new, because there was also one of the constant during the initial stages, that was the supply, especially the natural gas, ethane, propane supply. That was the problem in the initial stage, but now as we cannot afford to lose the natural gas, and all the natural gas that is being, that has to be utilized. So, the more and more cracker plant based on the your gas cracker plants are coming. FCC has been also developed into a major upgrading process in the petroleum refinery, as I told you, for the conversion of the heavy fuel oil into more valuable products ranging from light olefins to naphtha and middle distillate. Now, FCC are being operated in the propylene mode. So, this already I had discussed about the how the changes that is taking place in the FCC, even changes in the raw material which are taking. Now, you are talking about the residue FCC also. So, the even the product which you will be getting, that will also vary depending upon the operation of the FCC and the feedstock. So, the large amount of C4 and C5 compound are produced along with the production of ethylene in the steam cracker and the gasoline in the FCC. So, this, because the, as I told you, during the fluid catalytic cracking, although earlier most of the refineries they were operating the gasoline and the propylene, that was less, but now we are, that is the propylene that is going as high as above 15%, 15 to 20%, or as it may be 25%. So, the now the um, large amount of the C4 and C5 compound, they are available from these plants. C4 and C5 steams are important source of feedstock for butadiene, oxygenates, synthetic rubber, chemical intermediates, which are finding wide application in the organic chemical industry. With the increasing demand of C5 hydrocarbons and oxygenates, upgrading of C4 and C5 steam from steam crackers and the FCC, that the catalytic crackers, is important to the economic performance of the above process. It also provides a rich resource of reactive molecules which forms the backbone of the synthetic rubber industry, as I told you, the isobutylene or the butadiene or the isoprene, which you are getting from the naphtha cracker. The quantity and composition of the C4 and C5 steam depends on the severity of the steam cracker operation and the feedstock being processed. As I told you, I discussed while discussing the naphtha cracking, the product stream which you are getting, that will totally depend upon the type of the feedstock. Let me clear here two things about the regarding the C4 and C5 steam. You must know about the difference between the C4 C5 steam of the FCC and the C4 C5 steam of the cracker plant. What is happening in case of the C4 and C5 of the FCC? We do not have the butadiene fraction, that is very negligible amount is there, but in case of the cracker, naphtha cracker, we are having lot of the butadiene, especially in the naphtha cracker. So, the wherever we are having the naphtha, as I told you, the 52% of the feedstock is through the naphtha cracker, and still most of the your cracker plant, they were earlier based on the naphtha feed, but some of the now the gas based cracker plants are also coming. So, the whatever the product we are getting, that will be different in the composition. Your butadiene fraction will be only in the naphtha crackers, not in the FCC. The rest of the processing steam which you are having for upgradation, they are almost similar. This is the typical composition which I was telling, that the in case of the your, here you see the butadiene percentage that is there in the butadiene, isobutene, 1 butene, 2 butene, both the butenes are there. This is the typical composition of the steam cracking from the C5 fraction that we are having, and here you see this isoprene and the cyclopentane. These are the two very valuable products there. This is not butenes here, but that will be the N, means that will be the isoamylines which are producing, the amylines which are using. So that is there. So the C5 cuts from the steam cracker and FCC can be processed for recovery of the valuable C5 chemicals. Steam cracker C5 cuts contain unsaturated hydrocarbon that can be upgraded, particularly the isoprene and the cyclopentane, as they are present in reasonable high concentration when naphtha feedstock is used. This is the typical composition of the C5 cuts, and here you see the percentage of the isoprene around 13%. So that will vary 8 to 13%, that may be there. Pentadiene is also there, cyclopentadiene is also, because now there is a solvent that we are using, the cyclopentadiene dissolvent that we are using. So the importance of the cyclopentadiene, at the same time iso, this I was telling there in the butene, that is the, that was the methyl butene, not the butene C4, but it is the methyl butene which we are using for making of the TAME. These are the, you can see the broad range of the product you are making from the butadiene and the, so for the development of the synthetic rubber is concerned, that was only because of the availability of the butadiene and the SBR, that is the styrene butadiene rubber. So that is still the major portion of the rubber that is from the synthetic styrene butadiene rubber. So the butadiene that has played very important role in the overall economy of the cracker plant, where we are having the naphtha cracker, because a lot of the butadiene that is available. So these are the some of the products, because in case of the here is the both the SBR that you can make, different grade of the SBR that can be there, polybutadiene rubber, because normally many of the petrochemical complexes, instead of going for SBR, because if you are going for SBR, then you need the ethyl benzene to styrene. So they are making the polybutadiene. Even in Haldia they are making the polybutadiene, and not only in the Reliance Hajra they are making the polybutadiene. Even some other plants are also having the polybutadiene. Nitrile rubber, nitrile means the combination of the styrene, acrylonitrile rubber that you are having. Pyridine vinyl rubber, SBS, SEBS, elastomer, styrene monomer, N-octanol, ABS resin, MBS resin, adiponitrile. This is the one of the very important outlet for the hexamethylene diamine and adiponitrile in the manufacture of the nylons. 66, where you need the hexamethylene diamine and the adipic acid for making the nylon salt, and then which is the polymerized to nylon 66. Then the ethylene, norborine, laurylactam, cyclooctadiene, 1,4-butadiene. This is also very important. Tetrahydrofuran, sulfolane, 1-octane, and other species. These are the some of the major outlet for the butadiene. Similarly, the butene one, because the butene one that is also one of the very important feedstock, and especially when you are having the LLDP comonomer 1-butene we are using, and some of the actually the where plants they are making the butene one from other sources. So butene one, that is both the butenes are available, that you can separate the butene. SDP comonomer, N-butylene oxide, N-butyl mercaptan, specialty chemicals, 1 polybutene. So these are the some of the product of the butene one. Then the mixed butylenes, 2-butanol, C4 pyrolysis gasoline, methyl ethyl ketone, 2-propyl heptanol, malic anhydride, hydroxy alcohol, C4 alkylate, propylene. Because the C4 steam which I discussed while discussing the petroleum refinery, I told you the alkylates they are going to be important um, part of the reformulated gasoline, and already in other developed country, in other or the some of the Middle East country, they are already having the alkylation plant there, and they about I think it is around 10 to 12% of the total gasoline is from the alkylation process. So the C4 C5 ice that is going to play a very important role. Similarly, the other your isobutylene, which I told you that is very important, isobutylene that you can go for the manufacture of MTBE, ETB, polybutylenes. These are the three major. Apart from the long list is there butyl rubber, polyisobutene, methyl methacrylate, isoprene monomer which you are getting, peroxide intermediate that you are adding, and tertiary butyl mercaptan, butyl alcohol, and some of the specialty chemical and diisobutylene. This is the uh, product profile of butane, acetic acid, malic anhydride, 1,4-butanol, butyl lactone, propylene oxide, tertiary butyl alcohol. This is the complete list of the product which I discussed there. The mixed C4 steam, butadiene, isobutylene, MTBE, TB, 1-butene, the mixed butenes and butanes. So all these products already have discussed separately in detail, and the various product valuable products which you are getting from the C4 stream. Now let us discuss, we have discussed about the C4 stream of the um, various products which you are getting from the C4 stream. As I told you, the one of the very important um, products are the hydrocarbon, C5 hydrocarbon that you are getting, that is the isoprene, and these are the some of the major uses of the isoprene. Another very important constituent of the C5 steam is the 2-methylbutene and 2-methylbutene 1 and 2-methylbutene 2. These are the two actually the hydrocarbon that we are using for making of the stem. Synthetic mask, that is also we are using amide, benzene, hydrogen. These are isoamylines that we call the amylines. Hydrogen peroxide catalyst 2,4-dimethyl phenol photographic complex, phenadone which you are getting there, the crop protection chemicals, pharmaceutical industry, amylines, tertiary amyl methyl which are telling that this is the same amylines that same we are getting. Pentenes, organic synthesis in the polymerization inhibitor. Cyclopentadiene that you are making the chlorinated hydrocarbon, hexachloropentadiene, agrochemicals, then the cyclopentadiene, cyclopentane, elastomer, pharmaceutical, crop protection, flame retarder, and then the another important product we are getting pipeline for the polymers and the malic anhydride. This is the complete list of the C5 hydrocarbons. Already I discussed that from the isoprene what are the various product we are getting, and the um, these are the various actually the uh, major product derived from these hydrocarbons which are getting from the C5 steam. Now let us discuss the processing of the C4 steam, because we are getting C4 and C5 cuts. So let us discuss for the C4 cut from the steam cracker, because in normal the C4 that has to be separated from the C5. The C4 cut from the FCC and the cracker plant, there is not much difference in the, as I told you, in the processing of the C4 steam after the recovery of the butadiene, because the butadiene is only present in case of the naphtha cracker plant, not in case of the FCC. So the after the extraction of the butadiene, the other steam which is left, the processing scheme is same. whether it is from FCC or it is from the naphtha cracker. C4 steam butadiene from C4 steam of the naphtha cracker, the gas is first recovered. It is more in the, it is higher in the naphtha cracker, gas cracker it is less, followed by separation of the isobutene, because first stage is the separation of the butadiene from the other C4, means the isobutylene, isobutene, butene 1, butene 2, from C4 steam, FCC and cracker using various processes like etherification, hydrolysis, cracking, adsorption, hydro hydro isomerization, all those processes that we are using for the separation of the various steam. And adsorption is also because the, you see the Olex process for the separation of the some of the close boiling point olefins that we are having in the case of the separation of the um, butene 1. Butadiene is the important raw material for the production of large number of the synthetic rubber and the polymer such as styrene butane. Already I have discussed about the various outlet of the butadiene. Other fastest growing use of the butadiene is in the manufacture of adiponatile and the hexamethane diamine, which I told you, in the manufacture of nylon 66, because nylon 66 and nylon 6, these are the two major synthetic fiber which are playing very important role in substituting the conventional cotton, because the, in case of the tire cut lining we are using the nylon 66 which is having the higher melting point than the nylon 6. So, steam cracker and catalytic dehydrogenation of the butenes are the two major source of the other sources of the butadiene. Butenes can be recovered from the C4 or produced by dehydrogenation of the butenes, because the butane is also available in that steam, and that is why even the butenes which are there, that can be used for making some of the valuable products. So, let us discuss about the butadiene. What are the sources of the butadiene? Here I am discussing butadiene because the butadiene one of the important chemical, and so we are, instead of discussing separately, I am discussing in this chapter. The sources are steam cracking of naphtha. Other sources are also there, because you see the cracker, the steam cracker, that is not very old. So, the earlier also the butadiene is available. And SBR long back we started in Bareilly, that was the synthetic and chemicals Bareilly, where they are the SBR that was started long back before coming of the your cracker plant. So, catalytic dehydrogenation of butenes, catalytic dehydrogenation of butenes, dehydrogenation of the ethanol. This was the process that was being used for the butadiene earlier, when it was not available from the cracker plant. This is the actually the reaction that is taking place in case of the catalytic dehydrogenation of the butenes to butenes, two catalytic dehydrogenation of butenes to butadiene. This is also, sorry, this is also butadiene. Now let us discuss about the separation of the butadiene from the other C4 fraction. So, first stage is the selective hydrogenation of the feedstock to remove the arsenic compound, which is not needed in case of the, when we are using the butadiene for the synthetic rubber in the polymerization. That is undesirable part. Here the catalyst, as we discussed there in case of the naphtha cracker also, palladium catalyst very commonly in the hydrogenation reaction. Then the next step is the extraction of the butadiene. So, we are having the two methods, when the extraction by cuprous ammonium salts, or the extractive distillation using the dimethyl formamide, and other solvents are also available. The absorption of the butenes 10 to 15 times less than the butadiene. So, the, because the butenes, they are having the close boiling point and to the butadiene. So, preliminary absorption of the acetylene compounds by 20%, wet solution of the ammonium acetate and the desorption at 65 degrees centigrade, followed by the desorption of the acetylene compound. So, the separation that takes place. and absorption desorption for butadiene removal. These are the some of the steps involved in case of the extraction process. Now let us discuss about the extractive distillation part of the butadiene separation. Various solvent used are acetonitrile, because different with the continuous development there has been in case of the solvent also, because the phenol, furfural, these were the initial solvent that was available, but with the coming of the manufacture of the dimethyl acetamide or dimethyl formamide also that is being used. So the lot of the changes that has taken place in case of the your solvent extraction process. Here the process step the extractive distillation of the acetylene compounds and extraction of the butadiene and separation of the other C4 hydrocarbon. This is the um, process that we are using in case of the, this is the requirement of the butadiene for the polymerization grade. So the impurity that has to be removed. Now let us discuss about the isobutylene. Isobutylene, which is present because after the separation of the butadiene from the cracker plant, that can be combined with the FCC. How? Because this is how the integration of the refinery and the petrochemical that may be there. So the from the cracker which you are getting the C4 after separation of the butadiene, that can be combined with the C4 fraction of the refinery, and then further processing can be done, or depending upon the situation it can be separately processed in the refinery or in the your the cracker plant. So the isobutylene is present in the C4 stream of the naphtha cracker and the FCC. Major application of the isobutylene is in the manufacture of the gasoline blending components such as MTBE, ETB, alkylation, as I told you in alkylation, use of the isobutylene as the alkylate engine, that is it has a very high scope polymer gasoline that you are getting, means dimerization part which I discussed while discussing the petroleum refining, the polymerization part. The polymer grade isobutylene can be made by cracking MTBE or by manufacture of polyisobutylene, because you see the here what we are getting the isobutylene in case of the polymer grade in the pure form. So MTBE which we are getting, then that can be cracked and then you can get back the isobutylene. So isobutylene is used in the manufacture of butyl, which is made by the copolymerization of isobutylene with a small amount of isoprene. Isobutylene from the C4 steam cracker. First isobutylene is converted to MTBE by purification and recovered by cracking of MTBE to get polymer grade isobutylene, as I told you. So either suppose the in case of the after the purification MTBE direct it can go to the gasoline pool, or further it can be cracked to get the isobutylene. It is also obtained by hydration of the isobutylene containing the steam and then cracking, because the isobutylene containing steam, that will be hydration, and after hydration then the again cracking will get back the isobutylene. So these two routes are available. So isomerization of the butane, isobutylene can be also produced from the butane by isomerization using zeolite. So this is the separate stream, it is not connected with the recovery part, but the as the butane is available, so butane that can be used for making of the, this is another route that you can get the isobutylene. As I discussed about the importance of the butene 1 is the comonomer in the production of the low density polyethylene and high density polyethylene. Butene 1 can be separated from C4 stream of the cracker after extraction of the butadiene and separation of the isobutylene. After the remaining fraction of the C4 stream, that will be used for the separation of the butene 1. Separation of the 2-butene involves hydroisomerization and subsequent distillation for separation of the isobutene and the 2-butene rich cut. This is the complete process that we are having, the and different cuts, and this is going for the selective hydrogenation of acetylene and then the butadiene extraction, and finally we will be getting the butadiene. Then the steam from here that can be combined with the C4 cut from the FCC, then it will go to the MTBE, and MTBE then either by cracking you can get the MTBE, or it will go the your hydrodeacetamization process. So let us discuss in detail about this steam. So this is the, you see the, similarly here you can go selective hydrogenation, adsorption on the molecular sieve distillation for the separation of isobutene and 2-butene. Here the cracking MTBE, or it will go for the further separation. Similarly methanol, MTBE, that you are, if you are interested in the MTBE and isobutylene, then methanol, the cracking, or which I told you the process, hydration and then the decomposition, then you can get the pure isobutylene of the polymer grade. So this is the process that we are getting, then the hydroisolation, and the finally the you will be getting the various steam of the highly uh, pure steam of the isobutene and the 2-butene. So various actually the options are there for separating depending upon the requirement, as in the many of some of the refinery industry. Take the case of the Reliance, what they are doing, they are making the chain from the C5 steam, they are not going for the further path. Or in case of the IOC Vadodara, they are making the MTB, but as I told you there is um, MTB is very carcinogenic. So MTB as such, it is having it is not having so importance as it used to be earlier, but definitely if you want to make the isobutene, so the isobutene that can be separated, or butene one, because there are other routes are also for making the butene one, because in the petrochemical complexes they are making from other route the butene one, because that is their requirement. But that can be separated, because definitely you have to add more and more units for the separation of the these C4 gases or the C5 gases. So this was, I was telling, the normally what is happening, you will have to combine the steam C4 steam after separation of the butadiene or the butene, and then it will go to the final separation of the various product, low purity isobutene, high purity isobutene. So hydrodeacetamization is there. So this is the process that can be used for the 2-butene. Similarly, this is the process which I discussed about the butadiene, that is selective hydrogenation of the acetylene, butadiene extraction, and then the butadiene. Then the C4 cut of the FCC and steam cracker, that will go to the MTBE synthesis, butadiene hydroisomerization, which may be there present, so and butene will be getting, and then the MTBE, here the MTBE rich steam that will be getting. Similarly, this is the another steam that which I was telling, it may be cracking or it may be the decomposition after the MTBE synthesis or the hydration, then you can get the isobutene of the polymer grade. These are the other steam that you are getting separation of the 2-butene. Similarly here the adsorption molecular sieve, because this was the process developed by the UOP OLEX process for the separation from butene using the zeolite adsorbent, and then it will go to the further distillation, and then the steam that will contain the isobutene and the 2-butene. So any of the combination that may be there in this processing of the C4 steam. Now let us discuss the upgradation of the C5 cut for the recovery of the C5 chemicals which is present in the cracker plant, or the naphtha cracker especially. The naphtha steam cracker C5 steam is rich resource of olefins and diolefins which can be upgraded to produce elastomer resins and the valuable chemical intermediates. Important C5 dienes and the olefins are isoprene, cyclopentadiene, piperidine, isoamylene, dicyclopentadiene and the pentene one. Because in case of the cyclopentane, what we are doing, we are first we are converting the dicyclopentane, then again dicyclopentane converted to cyclopentane. So I will be discussing now. The C5 cuts from the steam cracker and the FCC can be processed for recovery of the valuable C5 chemicals. The steam cracker C5 cuts contain unsaturated hydrocarbon that can be upgraded, particularly the isoprene and the pentadiene and the cyclopentadiene, as they are present in reasonable high concentration when naphtha feedstock is used. Cyclopentadiene is easily dimerized to higher boiling dicyclopentadiene and separated from the C5 steam by simple distillation, because here also the problem of the close boiling point fractions are there. So both the combination of the fractionation and the adsorption process are the distillation that we are using here. We are using the liquid extraction or the extracted distillation using some of the solvent. So cyclopentane is easily dimerized to higher boiling dicyclopentane and then it is separated after making of the and the C5 steam by simple design. Cyclopentadiene, which I told you, can be cracked to get back cyclopentadiene, which is having the more value than the dicyclopentadiene. Then after the separation of the cyclopentadiene, isoprene is separated by extractive distillation from cyclopentadiene free C5 steam using dimethyl formamide, because dimethyl formamide, now the solvent which was not earlier available, now the many of the fertilizer plants they are making the dimethyl formamide from the synthesis gas. So with the availability of the DMF, even in case of the acrylic fiber also, for the as it saw for the in the dye spinning, the DMF that is being used. So distillation remove the light ethylene from the isoprene propylene, which is further separated by fractionation. So after the extractive distillation, we are separating the isoprene part, and then the isopropylene and propylene fraction, again they are separated from the light ethylene, and then this steam isoprene and propylene steam again further separated by distillation. So isoprene 99%, propylene around 75% that you are getting purity. This is 60, not 60 to 75%. Now as I told you, the one of the very important product which we are getting from the C4 C5 steam, that was the MTBE, TAME and the ETB. So several oxygenated fuel components have figured prominently in refinery reformulated gasoline planning, especially with the phasing out of the tetraethylate methyl tertiary butyl ether that play important role, and with the availability of the alcohol also we can go for the ethyl tertiary butyl ether. And already we discussed in case of the while discussing the petroleum refinery module 6 the properties of the various oxygenates which we are getting, the octane number, improvement in the octane number, then the oxygen content. So all those things that already I have discussed. So here I am not going, only the process, how we are making the process, these oxygen that we will be discussing. So the MTBE, tertiary amyl methyl, TAME, which we called it, and ethyl ETB, these are the three major oxygenates which we are producing from the C4 and C5 steam. All oxygen fuel reduced hydrocarbons in the automobile exhaust. MTBE was considered as one of the most important oxygenates used in the production of the lead-free gasoline, which I told you, and was produced on a large scale throughout the world, but without, after the environmental constraint, the problem with the carcinogenic nature of the MTBE, they are in band. So then again the units are changing from the MTBE to the other product, value product. But let us discuss the process. MTBE, which is made by etherification of the C4 acid from the trichar and FCC, is also used for the production of the polymer grade isobutylene, which we discussed while discussing the separation of the various C4 gases from the FCC and the cracker plant. There are two processes by which the MTBE is made. One is the conventional process, one stage process, and the reactive distillation, where the reactor followed by reactive distillation column, where both the reaction distillation simultaneously taking place. So the finishing stage, you can say, the main reactor and then finishing reactive distillation unit is there, and so this both the process that is being used for making of the MTBE. This is the process that we are getting here, C4 cup. This is by the conventional process. After the methanol, that is a you are having one reactor, but in case of the your this is the your feed preparation part. This is the MTBE synthesis part, where methanol that is being added for etherification, then MTBE reactor that is going. Two reactors are there, then the fractionation. In case of the two-stage process, we are having the reactive distillation part also, then MTBE fractionation, you are separating the MTBE, then the methanol, unreacted methanol that is separated, and that is again recycled to the reactor. So this is the process. There is not much difference between the reactive distillation, only the efficiency that is better. We are having the finishing stage reactor distillation also there, that is the difference. Similar process also, the same type of the flow diagram is also for making the same. This is the reaction that is taking place, the isobutylene and the methanol that is reacted, and we are getting the methyl tertiary butyl ether.